from a lonely watch post, almost 1 million miles from our world. The James Webb Space Telescope is silently observing the cosmos. It's a time machine, built to look back toward the dawn of the universe, to see the very first stars and galaxies flicker into existence. But sometimes, the biggest questions don't come from the farthest corners of space, but from the darkness right in our own backyard. This was supposed to be just another observation, a long, patient stare into the blackness at the edge of our solar system. But what if Webb saw something that sent a shockwave through the entire scientific community? Imagine a mysterious light shining from 7 trillion miles away, a light that, by all known laws of physics, simply shouldn't be there. For the first time, we'd be forced to ask, are we looking at a spectacular, undiscovered natural wonder? Or are we seeing the first glimpse of city lights from a civilization that isn't ours? Today, we're going on a journey to the absolute edge of our solar system. We're going to explore a hypothetical discovery that would challenge everything we think we know about our place in the universe. We'll look at the real science and the real technology that even lets us ask this question. What would happen if we found a light in the dark? And what would it really mean? The ultimate frontier, 7 trillion miles. It's a number so big it's hard to wrap your head around. It's more than 75,000 times the distance from the Earth. To the Sun, it's over 1,000 times farther than Pluto's orbit. Out here, you're not just in deep space, you're in the deep interstellar ocean. This is the realm of the Oort cloud. For most of history, we figured the solar system ended with the planets. Then we discovered the Kuiper Belt, that frigid, icy disk of cosmic leftovers where Pluto lives. But way beyond that, there's another, even more mysterious region. The Oort cloud is a giant theoretical sphere of icy objects thought to wrap around our entire solar system like a massive shell. It's a ghost. A hypothesis we came up with because of the paths of long-period comets that sometimes swing by Earth. We have never actually seen a single object within it. It remains pure theory, the final, uncharted frontier of our sun's gravitational reach. Think of it as our solar system's attic. It's dark, cold, and full of ancient junk left over from when the planets formed 4.5 billion years ago. From out there, our sun would just be another bright star in the sky. The temperature is just a few degrees above absolute zero. It is a place of absolute silence and stillness. So why are we talking about it? Because finding anything there would be incredible. But finding a light source, that would change everything. In the frozen, dead quiet of the Oort cloud, there just shouldn't be any light. The icy rocks and comets that live there are inert. They don't burn, they don't shine. Any light from this region would instantly break all our models of the solar system. It would be an anomaly so huge that scientists would have to ask a question they've long prepared for, but never truly expected to face in our lifetimes. Is it natural, or is it something else? The anatomy of a mysterious light. So, what would this impossible light even look like? What clues would make an astronomer's heart skip a beat? To get it, we have to understand how light normally behaves in space. Most natural light is, well, messy. Stars flicker and flare. Nebulae give off a gentle, diffuse glow from superheated gas, spread across enormous clouds. Supernovae are insanely bright, but they're one-off events that fade away, and artificial light would be different. Scientists looking for technosignatures, the technological fingerprints of alien life, have a kind of checklist for what to look for, and our hypothetical light from the Oort cloud would tick a lot of boxes. First, there's consistency. Imagine a light that is perfectly steady. It doesn't twinkle like a star or pulse like a pulsar. It's just a constant, unwavering glow. That kind of stability suggests a controlled power source, not the beautiful chaos of astrophysics. Second, the structure. What if it wasn't just a single point of light? What if Webb's cameras revealed a collection of lights in a distinct pattern, something that gravity and nature could never arrange on their own? That would be a jaw-dropping discovery. It's defying the random way objects usually cluster in space. But the real smoking gun would come from the light spectrum. By using an instrument called a spectrograph, scientists can split light into its basic colors, like a prism. This creates a unique barcode that reveals exactly what something is made of. Natural light sources have barcodes we can predict. But what if this light's barcode was unnatural, A 2021 study explored this very idea, proposing that the Webb telescope could theoretically spot powerful artificial lights on a planet like Proxima b. The researchers noted that lights like LEDs give off a very specific narrowband signature, totally different from the broad spectrum of a star. If our Oort cloud light showed a similar barcode, a sharp spike in one specific color, it would be almost undeniable. It's like finding a laser beam in a forest of candles. It would be a fingerprint that says, "I was made." The eye of Webb's? This all just a fun science fiction thought experiment? Could we actually see such a faint signal from so far away? The answer to that question lies with the most powerful space telescope ever built, the James Webb Space Telescope. Webb isn't observing from the Oort cloud. It's parked at a special spot about 1,000,000 miles from Earth, called Lagrange Point 2. This location shields it from the sun's glare and Earth's heat, giving it a crystal clear view of the infrared universe. And that's key, because infrared is the wavelength of heat, and it's where the cosmos hides its best secrets. Webb has several incredibly sensitive instruments. But for our mystery light, one is the star of the show, MIRI, the mid-infrared instrument. MIRI can detect the faint thermal glow of objects colder and more distant than anything we've ever seen. If some civilization was generating heat and light from cities or industry, MIRI is the tool that could potentially spot that faint warmth against the near absolute zero cold of deep space. Here's how it would probably go down. First, Webb would have to spend a long time staring at a single, dark patch of sky in the direction of the Oort cloud. This is called a deep field observation. Its giant 6.5-meter mirror would soak up every single photon it could. If a tiny point of light showed up on its sensors where there should be only blackness, alarm bells would start ringing. The next step would be the all-important spectroscopy, using its near-infrared spectrograph, INRI-SPEC, or MIRI's own spectrograph. Webb would run that chemical barcode test we talked about. This is the workhorse of modern astronomy. It's how Webb has already found water vapor and carbon dioxide in the atmospheres of planets hundreds of light years away. In our scenario, Webb would read the barcode of the mystery light, would analyze the wavelengths to figure out its temperature, what it's made of, and where it's coming from. Is it just reflected sunlight bouncing off a weird icy object? Spectrum would match our sun's? Is it some unknown natural chemical reaction? The barcode would show the fingerprints of the elements involved, or is the spectrum completely unnatural? Is it narrow, focused, and missing the signs of any known star, gas, or mineral? This is the power of Webb. It doesn't just see a light, it interrogates it. While the Oort cloud is unimaginably far and dark, Webb's sensitivity is pushing the boundaries of what's possible, letting us seriously consider a search that was pure fantasy just a decade ago. Natural wonder or alien beacon? But before anyone declares we found ET, science has to be its own biggest skeptic. The rule is simple. Extraordinary claims require extraordinary evidence. So what could this light be if it's not artificial? The first and most likely suspect is a simple glitch. Webb is a hugely complex machine, and its data is raw. A stray cosmic ray could hit the detector just right, or a bug in the software could create a false positive. Any signal would be checked and double-checked by teams all over the world to rule out a simple error. Okay, let's assume the light is real. What natural thing could be happening in the Oort cloud to create it? This is where scientists would get creative. Maybe it's an ice volcano on a large object, shooting out crystals that catch the faint sunlight in a strange way. Maybe two objects collided, creating a temporary flash or a cloud of reflective dust. Another wild idea involves cosmic rays. The universe is full of high-energy particles. Perhaps a large object in the Oort cloud, made of something unusual, reacts to this constant bombardment by glowing through a process called luminescence. It's a long shot, but every natural explanation has to be explored first. Then there's the massive hurdle of energy. For us to see a light source with Webb from 7 trillion miles away, it would need to be unbelievably powerful. The energy needed to make city lights visible at that distance would be astronomical. far greater than what our entire world produces. This is a major problem for the alien hypothesis. And we have to remember, the Oort cloud itself is still just a theory. We haven't even directly seen one thing in it yet. So any discovery out there would first be a lesson in the physics of our outer solar system, long before it would be a lesson in astrobiology. The scientific community would spend years debating, modeling, and testing natural explanations before the word alien would ever be officially used. It's a slow, careful process designed to make sure that when a discovery is finally announced, it's built on solid ground. The human quest, this whole thought experiment, this grand what if, is really about a question that has followed us through history. Are we alone? It's the question that drives so much of our desire to explore the cosmos, and it's a question Webb was, in part, built to help answer. While our story about lights in the Oort cloud is just a hypothetical, the search it represents is very real. Every day, Webb is collecting data that chips away at this enormous mystery. It isn't actually looking for city lights in our solar system, but it's doing things that are just as revolutionary. It is staring at worlds orbiting other stars and reading the chemicals in their molecules. JWST has given us stunningly detailed views of the atmospheres of exoplanets like the hot Jupiter HD 189733b on the super-Earth 55 Concrete E. It's searching for gases that could tell us if a rocky world has a real atmosphere. Each of these discoveries is a critical piece of the puzzle. Finding water tells us the ingredients for life exist elsewhere. Detecting molecules like methane gives us clues about a planet's geology, and maybe, just maybe, its biology. These are the real discoveries happening right now. May not be as dramatic as a single, mysterious light, but they are patiently building the scientific case for where we should look next. Webb is creating a map of the most promising worlds in our galactic neighborhood, pointing the way for future telescopes that might one day be powerful enough to find the final proof of life. This level of discovery is what modern astronomy is all about, pushing the limits of technology to answer our oldest questions. If you're fascinated by the mysteries JWST is unlocking and want to stay on the front lines of space exploration, make sure you subscribe to the channel. We're all on this journey of discovery together, and there's so much more to explore. So, have we found cosmic lights from 7 trillion miles away? No. As of today, the Oort cloud is as dark and silent as we've always thought it to be. There are no confirmed detections of anything artificial at the edge of our solar system, but the use of silence doesn't mean no one is out there. It just means our search has barely begun. For the first time in history, we have an eye in the sky powerful enough to spot the anomalies. Read the chemical barcodes and turn what was once science fiction into real science. The James Webb Space Telescope is our silent watchman, and its mission is far from over. The story of a light from 7 trillion miles away may be a fantasy for now, but it reminds us of what's possible, pushes us to keep looking up, to keep asking the big questions, and to keep exploring, because somewhere in the vast, cosmic darkness, an answer is waiting. We're finally building the tools to go find it.